Here's the 4-3 suggested assignment. I'm going to start with problem number 1. It says the given point lies on the terminal side of an angle theta in standard position. Find the values of the 6 trigonometric functions of theta. So basically the idea here is that you're going to plot the point 3, 4. And you're just going to draw line from the origin to it. Basically that's your angle, and what you're going to do then is you're basically going to make it a complete triangle. So in this case your x value is going to be 3, your y value is going to be 4, and you need to find what is the radius, or also known as the hypotenuse. So in this case we're going to use Pythagorean theorem. We have 3 squared plus 4 squared equals c squared. And so 3 squared is 9, 4 squared is 16. Together they make 25 equals c squared. And when I square root both sides, I'm just using positive 5. Basically your radius, or the hypotenuse in these kinds of problems, even with the coordinate plane, will always be positive. So this is 5. Now your angle theta is down here, okay? So basically you're going to do opposite over hypotenuse. So let me just write all my trig functions. Sine, cosine, tan, you should be familiar with. Like really familiar with. So TOA if you need it. Honestly, I write it just so I can see it. It helps me to be faster. From there, you need to know which ones go with which. So tangent goes with cotangent. Cosine goes with secant. And sine goes with cosecant. And the way I remember that is tan and cotangent both have the word tangent, but then for your S's and C's, it's always an S with a C with an S. So that's how I remember which ones go with which. All right, so from this angle, if I want opposite over hypotenuse, I'm looking at 4 over 5. Cosine is adjacent over hypotenuse, so 3 over 5. And then tangent is opposite over adjacent, so 4 over 3. These are just these flipped. So basically 4 over 5 becomes 5 over 4, 5 over 3, and 3 over 4.